going CQ, CQ, CQ 20 meters. I am filling in for him this evening, and we're going to do a presentation on antenna disconnects. So this project I just completed, I did at my house, my home shack, and basically I had some antenna cables coming up to my second floor shack that came in through the window, and so when I wanted to connect the radios up, I had to connect through the window, open the window up, bring the cables in, connect up, and then disconnect when I wanted to get off the radio. So we didn't take any lightning or bring any stray voltage into the Radio Shack. My wife was not too happy about the aesthetics of it because the cables came up over the porch roof and hung down in the view of the porch and into the yard. And I wasn't too pleased about it either, to be quite honest. So I ran some cables up through the attic into the shack and back out the side of the house and down along a corner of the house and out to the yard where the antennas are at. That being said, I needed a way to disconnect them without having to go outside and do those kind of things. So basically, I wanted to be able to remotely disconnect the antennas without physically going out there and taking them apart. We wanted to have active surge and lightning protection. I wanted it in a waterproof enclosure, and I wanted some way to select which antennas I wanted to disconnect because I've got several antennas. So I was at the Shelby Hamfest a couple years ago, and I ran into Dan Grevereau, N1ZZ, and Dan was one of the principals at West Mountain Radio. He since is parted with West Mountain Radio and now has his own company, Paradan Radio. And he makes a really neat antenna disconnector. And so it's pictured here on the screen. This is the dual model. He makes a single model as well. And this seemed to be a good solution for me, so I purchased one and subsequently have purchased a second one to take the other antennas and disconnect them. It will handle 1,500 watts, greater than 1,500 watts each on each of the inputs. It runs on 9 to 18 volts DC, draws about 120 milliamps at 13.8 volts. Very low insertion loss, less than 5/100ths of a dB, under 10 meters, and then 0.4 dB at 6 meters and 1 dB at 2 meters. The relays are 4 to 12 volts. I'm sorry, there's 4 12-volt relays in there rated at 15 amps and they're reverse spike protected. The active surge protection is gas discharge tubes, and the case is water resistant, not waterproof, hence the reason I wanted it waterproof. Take a look at the basic circuit. As you can see, it's 4 SO239 connections. There's a couple relays in each one of them, and you can see how it fits in on the unit itself. Very simple, elegant design. Everything's grounded to the case, and you have that big ground nut at the bottom there to take everything to earth ground. So I basically decided that I wanted to build a box to disconnect, to be able to power those disconnectors on and off. And I came up with a very simple circuit. It's 4 switches and 4 power pole connections. Now this will allow you to do 3 of the disconnectors, or 6 antennas. So I have a DC port in on the back with power poles, and that feeds a single switch. That switch is the master switch, turns on and off, and once it's turned on, you can have current flowing to the other 3 switches, which in turn will, if you turn those on or flip those on, they will go to the disconnectors, power the disconnectors up, and connect your antennas. I basically mocked the box up using some 20 amp toggle switches and the power pole connectors. Purchased a box from Amazon, a little project box, and I've got a better picture of it, but this is the box here, about $17. Great little box, solid, very easy to work in. The top comes off, the front and back panels come off. It's got a really nice frame inside of it. So in order to build the box, I went ahead and mic'd and measured all of the devices inside, and I went ahead and designed it in Visio, laid it out, printed that template out in 1:1 or basically to scale, grabbed it, taped it to the front of the panels on the box, and then I tapped those with a center punch to get the drill press ready to feed into those, drilled out all the holes, brought it back up, and then did the assembly part on it. As you can see, this is the completed box. We've got the 4 switches on front, main power, HF1 and 2. Right now I only have one of the disconnectors installed. The second one is right here with me tonight. And the other 2 will be spares at this point in time. If you look at the back side of the box, you see where the DC power comes in. Oh, went too fast, sorry about that. You can see where the DC power comes in, the antenna connections for port 1, port 2, port 3. Again, it's a very simple design, very easy to build. Anybody can build this thing. I've got an overhead view and oblique view of the box completed with the wiring inside. I did put a 5 amp fuse on the incoming DC power inside the box just to have a little bit extra protection. This actually plugs into the rig runner that I have on the back of my radio desk. I'm using a 1 amp switch, 1 amp fuse there, but just to give it a little protection. A secondary protection inside the box. Again, number 12 wire, very simple design. Used 1/4 inch spade connectors, quick disconnects to make all the connections, and of course the power pole connectors come with the little 30 amp power pole feeders. So, outdoor construction. I wanted a weatherproof box that I knew was hardy enough to handle the heat down here and the rainstorms and the wind we get down. So DX Engineering actually puts out a box. It's their UE2P box, and this is actually one of the boxes here. It comes with a nice metal plate inside of it. It's with antenna work and putting in polyphasers. The original box I bought has the polyphasers for my antennas coming into it. The only complaint I have about the box is that it's not quite big enough to maintain bend radiuses for LMR 400 or LMR 600. You can get away with it with RG8X or RG58 if you're using that. Why you would, I don't know, but RG8X would bend fine in this box. The box is designed for you to penetrate from the top and come in the bottom, leaving the box. Really not a good idea with a vertical penetration, even though they give you some watertight inputs to come into the box, basically box connectors with watertight gasket inside. Eventually those things will dry out, and when you have a vertical cable coming down into the top of a box, water's going to follow that cable, it's going to follow gravity, and it's going to find its way into your box. So what I did is I came in the bottom of the box. It has a really nice set of combs on the bottom of the box, neoprene sealed, keeps the bugs out. You can run your coax cables inside, and there are plenty of openings there for you to run the coax cables up into. And what's nice is you can actually use pre-connectorized cables because they slide in through the fingers in the box. So anyways, again, with the LMR 400 I'm using, it's a very tight bend, and as we all know, with RF, DBs don't have knees, so they don't bend to go around corners. They don't bend down to go around corners. So you want to keep those runs as straight as you can, or the bend radiuses as loose as you can. My solution was to use the 90-degree angle connectors to connect up from the box to the coax, and it kept my bend radiuses down, so I'm not messing up the foam core insulation on that center conductor. Now, to get power to the box, I ran 18.2, and I used an outdoor rated cable So no mystery there. It's just 2-conductor red and black, 18 gauge inside and outside plant shield. It's a hardy cable. It's UV rated and burial rated, so I can run it in a conduit underground. I can run it out exposed to sunlight, and it's going to last me a long time. In order to protect that and not have that bring current into the shack, if you look at the bottom of the box right there below the disconnector, you'll see a little box there with some orange tabs on the bottom, and that's basically a 12-volt surge suppressor. It's a solid state suppression, so basically it's a big diode, and it will only allow power to flow one way, and that's from the box to from the power supply through the box into that disconnector. Now the interesting thing about the disconnector, and I'm not quite sure why the design was that, but on the power lead coming to it, the power feed, it's got an RCA connector. So Dan does supply some power poles and some butt splices so that you can, at some point, if you want to, instead of using the RCA connector, you can go ahead and use the butt splices or the power pole connections and make up your connections there and have that. I decided to leave it with the integrity it was designed with, and I came up with a little pigtail that has an RCA connector on one end and an RCA adapter to an RCA adapter with a screw terminals, raw terminals to go into that protector, and then I just brought the 18.2 in directly from the shack into the other side of the protector. So that basically laid it out, and then of course to ground the box, I used some 1-inch braided copper strapping, and that stuff's fantastic. And if you're going to ground, and it's a little expensive, it's more expensive than number 6 or number 4, but it really does a better job grounding, especially non-insulated. So basically shoved it onto the binding post at the bottom for the ground, ran it underneath the plate, and that's an important thing is when you have that box there, everything on that box is grounded to the case of that metallic box, that aluminum box. So you need to ground that box as well. So I've got it in contact and screwed through that metal plate. And then that is all bonded. The strapping is bonded to it, and also the pigtail off of the 12-volt surge pressure is bonded to that. And that goes to an 8-foot ground rod that's driven in the ground very close by. It's within 18 inches of the box horizontally and about 2.5 feet below the box. So I've got it well grounded, and as you can see, everything's nice and neat in there. I've got to do a little labeling, but I wanted to get the pictures done, and it was raining the day I put this in, so I didn't get a chance to finish the labeling job. So we'll talk about the material list. Basically, it's one of the DXE enclosures. This particular one box, you're only going to get one disconnector in there. You just don't have enough room for two. Now, there's plenty of people who make bigger boxes, but they start to get really pricey when you talk about weatherproof boxes. Even the polycarbonate boxes get pricey when you start to go above, I think this is a 12 by 12 by 4. When you start to get up into the 18 by 18 boxes, they get pretty pricey. So, you want to try and find something that's going to be within your price range, but still do the job. This DX Engineering box is like 55 bucks, so it's very affordable, and it does a good job. Again, if you use an RG8X, you're not going to have a problem routing these things around. LMR 400, you're going to have to use 90-degree connectors. LMR 600, I don't know. I'd probably get a much bigger box. I used 4 right angle connectors to connect the 4 positions on that disconnector. I used about 10 feet of that 1-inch braided cord, which I ended up actually only using about 3 of the 10 feet I ordered. 1 5/8 by 96-inch ground rod, 4 wall anchors, 4 tapping screws, 18 gauge 2-conductor burial UV rated control wire. I actually had a reel from my daytime job. I just pulled off what I needed. I brought home about 100 feet, and I think I had, you know, about 4 or 5 feet left off it when I cut it. 3 sets of Anderson power poles. So you need one for the power connection in the back of the box. You need one for the 18 2 to go to the box, and then you're going to need one on the other end to connect up. So that gives you your 3 sets of power poles. For the project box, you need the project box. I got that off Amazon, like I said, very low cost box, but well built. Panel mount dual power poles. I got those from Quicksilver Radio. John B up there does a great job, and he has those things. They're about $20 a piece. You can get the square ones and put the power poles in those. Probably just as effective, a little less expensive, but harder to cut the square holes in the metal. Then the 12 heavy duty 20 amp toggle switches with the green LEDs. So my switches light up when you toggle them on, so I have a visual representation as well as feeling the click when it goes down. The switches you can buy from Amazon, you get them at Home Depot. You can actually get them, believe it or not, from DX Engineering. They're partners with Summit Racing, and Summit Races carries those. They're actually automotive switches. So you can get them there if you want to buy kind of everything in one place. The 18 gauge, I've used 10 foot of red and 10 foot of black silicone hookup wire. That's what I use to wire the inside of the box. Again, you can get that pretty much at any auto parts store, off Amazon, or wherever. And then, of course, the disconnect terminals. So you use about 12 of those to build the box. Again, it's not, the real expense is the disconnector. These things are about 190 bucks for the dual, but in order to have a solution for me that allows me to have peace of mind if I'm at work and a thunderstorm comes up, that my antennas are still connected, but I know the disconnector is an interrupt between them, plus I have polyphasers in line as well. So I've got 2 places where it's protected and goes to ground. If it gets a large spike of voltage or amperage, it allows me to do that. Now again, if I was going to be out of town for 7, 8, 9 days, you know, going on vacation or business travel or longer, I would definitely go out and physically disconnect. For me, I would disconnect at the polyphasers, and I would disconnect at the disconnector and actually make a physical connection. But it's worth it for me to have spent the money on the project I did to be able to go in the shack, turn on the flex, and flip the switch on and have my antennas connected. Same thing when I do my UHF VHF side. I will just be able to turn on the 710 and flip on the disconnector, and I'll have my antennas hooked up. So again, it's an elegant solution for a difficult problem. Just to give you an example of testing the project, here's a look at the box, and I'm on the flex. Now that one signal you see there is actually a neighbor of mine who is about not quite a mile away, and he puts out about 400 watts. And I can tell you, I picked him up on a broken piece of coax at about 5.9. So you can see it does a pretty good job. All the rest of those signals are coming in now. And that flex does have a really sensitive receiver in it. Plus I have the preamp gain up at 32 dB. So I've got it full blast, wide open, getting as much signal as I can get. So the box does a great job. It's a very easy build. You know, it took me, including drill time, maybe an hour to put the box together. Planned it out. Again, it's again very simple build, but very good solution, at least for me. Hopefully, it'll be a solution for you and solve some problems for you. Are there any questions about the? No questions at this point in time. So with that, I will say 73. Keep your passion for radio, enjoy it, and like and subscribe to the channel, and also ring the bell so you'll know when we go live and we have new content out there. So Good evening from Rock Hill, 7-3, and we'll look for you down the coax. This is NJ4Z. I'm out.
Parks on the air calling CQ 20 meters.